I want you to start by just taking a mental step back for a second.
Right.
Just think about the physical reality of how we power our lives right now. Like, imagine a reality where the massive, sprawling power grid that we rely on every single day.
The whole thing.
Yeah, the whole thing, those millions of miles of high-voltage lines, the huge substations sitting in your neighborhood, the coal plants, the nuclear facilities. Imagine all of it is just completely, undeniably obsolete.
Gone.
Just gone. Not updated, but rendered entirely unnecessary.
It requires a complete inversion of how we intuitively understand energy. From the Industrial Revolution onward, we've been conditioned to think of energy as something that has to be, constantly generated at a massive central hub.
Right, and then shipped out.
Exactly.
Yeah.
Transported at great expense over huge distances. But you are describing a paradigm where energy generation is hyper-localized, functionally infinite.
It's like the difference between relying on a citywide reservoir for your water versus having a magical spring directly inside your kitchen sink that just never runs dry.
That's a good way to put it.
Okay, so, listener, let's unpack this for a second. Because I know what you're thinking. You're probably thinking, I just pitched you the opening text crawl to a sci-fi movie.
It does sound like it.
It really does. But I'm actually looking at a stack of incredibly dense, heavily footnoted engineering blueprints. We're doing a deep dive today into a 2026 manifesto by an independent researcher named George James Dukas.
Yes, the Transdimensional Unified Field Theory V2, or TDUFT.
TDUFT. And within these hundreds of pages, he's proposing exactly that world. Imagine taking a single AA battery, right? You drop it into an electric vehicle, and that battery runs the car for its entire lifespan.
No charging stations.
None. No plugging it in overnight. And then it gets weirder. Imagine walking into a hardware store, buying a standard $15 light bulb, and knowing that inside that ordinary glass globe is a miniature nuclear fusion reactor.
A reactor that powers itself completely off the grid for 50,000 years.
It's a fascinating, complex, and frankly audacious text.
It is. Dukas is presenting what he claims is a complete theoretical physics framework. But he doesn't stop at the chalkboard. The theoretical framework comes with precise, machine-ready engineering blueprints.
Yeah, he's basically saying he solved nuclear fusion.
Which is a problem that has stymied the absolute brightest minds, the best-funded labs, and the most advanced supercomputers for 70 years.
And he's not just claiming to have solved it by building a bigger magnet or a hotter laser. He's proposing an elegant application of a single, simple quadratic equation.
Right.
We're going to explore how this one equation supposedly eliminates radioactive waste, solves fusion, and basically births $6 trillion industries.
Quantum computing, limitless data storage, deep space, Mars propulsion.
The sheer audacity of it is staggering.
Which is exactly why we need to maintain a clinical distance here. Whether this document is the greatest leap in physics since relativity, or just an incredibly elaborate piece of mathematical madness, the level of detail demands a closer look.
Oh, absolutely.
The math is highly rigorous. The engineering specs for his proposed reactor are mapped down to the nanometer. It's not just philosophy, it's a falsifiable blueprint.
Exactly. We aren't here to say, hey, this is the new reality. We're just here to say, look at the sheer scale of what this document is proposing.
We should probably start with the problem Dukas is trying to solve.
Yeah, the 70-year failure of nuclear fusion.
Yeah.
Because to understand why this manifesto is so wild, you really have to understand the billion-dollar wall that conventional physics has been banging its head against since, the 1950s?
Right. So let's ground this.
Okay.
For decades, fusion research has basically focused on two main technological approaches. First, you have magnetic confinement.
That's the giant donut-shaped ones.
Yes, the massive tokamak reactors. And second, you have inertial confinement, like the National Ignition Facility, or NIF, out in California.
Yeah, ones with the lasers.
Exactly. They use an array of the world's most powerful lasers to compress a tiny pellet of fuel.
And we have thrown, tens of billions of dollars at these projects. Countless brilliant careers. And what do we actually have to show for it? The document points out some pretty fatal flaws.
It does. Let's take ITER, for example.
The massive international tokamak being built in France.
Yes. The text notes it cost upwards of $25 billion, and its operational goal, the absolute pinnacle of what it hopes to achieve, is to maintain a plasma pulse for maybe 400 seconds a year.
Wait, 400 seconds a year? That's like 6 minutes of operation a day. You can't run a city on a power plant that turns on for 6 minutes a day.
It is the absolute definition of intermittent operation. And Dukas explains exactly why this happens. Conventional fusion is basically a fight against chaos.
Right.
To get atoms to fuse, you take a superheated plasma, heat it hotter than the core of our sun, and try to trap it. Now, plasma at that temperature desperately wants to expand. It wants to escape.
Naturally.
So in a tokamak, we use brute magnetic force to squeeze it together. We use massive cryogenic superconducting magnets cooled to near absolute zero.
Which feels like trying to hold water in your hands by just squeezing it as hard as you can.
Yeah.
It just squirts out between your fingers.
That is precisely the issue. You run into magnetic reconnection, plasma turbulence. The plasma physically fights the confinement. It takes an immense amount of electricity just to run those magnets.
Which is why achieving net positive energy has been so impossible.
Exactly. You are fighting the natural thermodynamic tendency of the material.
And it's not just the intermittent pulses. The document brings up the fuel problem, the reliance on radioactive tritium. There's barely any commercial supply of tritium in the world, right?
Very little. It largely has to be bred inside nuclear fission reactors.
Plus, conventional fusion produces all this long-lived actinide waste. High-energy neutrons bombard the reactor walls, making the massive steel and concrete structure highly radioactive.
Leading to hundreds of millions of dollars in decommissioning costs.
We're basically building radioactive monuments to our own inefficiency.
What's fascinating here is how Dukas reframes the core issue. In conventional attempts to synthesize superheavy elements, scientists use massive particle accelerators to smash beams of ions into heavy targets.
Okay.
But the probability of two nuclei actually hitting, fusing, and sticking together is governed by a metric called a cross-section. It's essentially the target area that an incoming particle must hit to trigger a reaction, measured in a unit called a barn.
Or, in this document's case, a picobarn. Dukas says the conventional cross-section for creating element 120, which is sort of the holy grail in this manifesto, is 0.034 picobarns.
Yes.
Now, listener, a picobarn is 10 to the negative 12 barns. It is an unfathomably small target. It's like trying to hit a specific grain of sand on a beach in California by firing a sniper rifle from New York, blindfolded.
That is an apt visualization. Statistically, it translates to roughly one successful fusion event for every trillion collisions.
Yikes.
You're spending massive energy accelerating trillions of ions, and 999 billion of them do absolutely nothing useful.
Dukas breaks down the math on this, and it's almost hilarious in a dark way. He points out that if you wanted to create just 100 grams of element 120 using current methods, it would take 4 times 10 to the 17th power years.
Yes.
4 times 10 to the 17th.
Yes.
The universe itself is only about 1.38 times 10 to the 10th years old.
He is mathematically demonstrating a fundamental dead end. You cannot build a business model around a process that takes 1 billion times longer than the age of the universe.
Which brings us to his proposed solution. And I gotta say, when I first read this part, I had to put the paper down and walk around the room. Because he says the solution isn't bigger magnets.
No.
The solution relies entirely on the golden ratio.
Yes. The mathematical constant phi, approximately 1.618, derived from the quadratic equation x squared minus x minus 1 equals 0.
Wait, hold on. The golden ratio.
Yeah.
Like the spiral of a snail shell. Or, the layout of seeds in a sunflower.
The proportions of the Parthenon.
Yeah. You're saying this document proposes we just apply the math of a pine cone to a nuclear reactor, and suddenly a 17 billion year process takes a few months.
Yeah.
That sounds like pure numerology.
I understand the skepticism. It's the natural response from anyone trained in classical physics. But he isn't using the golden ratio as a metaphor. He is positioning it as the fundamental geometric substrate of physical reality.
Okay, let's look at the mechanism. He introduces this universal quality factor equation. Q equals phi to the power of 4 delta n.
Correct.
And he claims that applying this specific geometry boosts the probability of fusion by a factor of exactly 2,207.
Think about resonance. If you push a child on a playground swing at random intervals, you expend a lot of energy, you get tired, and the child doesn't go very high. The motion is chaotic. That is conventional fusion. But if you push the swing at exactly the right moment, matching its resonant frequency, a small amount of energy results in a massive, perfectly sustained arc.
Dukas is arguing we've been pushing the swing randomly. It makes me think of a zipper. Conventional fusion is like taking 2 completely flat, hard pieces of plastic and trying to force them to stick by smashing them with a massive hydraulic press.
You're shattering the plastic.
Exactly. But Dukas is saying, stop smashing. Look at the edges. If you cut teeth into those edges and you just angle them perfectly, they slide together and lock with almost zero resistance.
That is a much better analogy. By organizing the target material, the californium, into a specific helical structure, the atoms naturally align to maximize fusion probability.
So you're writing geometric resonance instead of fighting thermodynamics.
Exactly.
But to really buy into this, we have to look at the underlying physics framework. Let's talk about what Dukas calls the master unification equation.
This is where the document transitions from engineering claims to foundational theoretical physics. He outlines a wave equation that bridges static geometry and wave propagation. And he repeats emphatically that it contains zero free parameters.
Right, zero free parameters. Let's explain why that's a massive flex. In the standard model of particle physics, there are roughly 24 free parameters, right?
Yes.
Like the exact mass of an electron or the strength of the strong nuclear force. The theory itself can't predict those numbers from scratch.
Exactly. Physicists have to go to a lab, measure those exact masses experimentally, and then plug those numbers back into the equations by hand.
To make the math balance out.
Right. A theory with free parameters is technically incomplete. It requires manual human tuning to match reality.
But Dukas is saying his master unification equation requires no tuning, no arbitrary numbers. It all flows naturally from x squared minus x minus 1 equals 0.
To achieve this, he uses the Eternum nexus. It has three fundamental operators: space, represented by 0, which is the void potential; point, represented by +1, which is particle localization.
Or a particle actually exists.
Yes, on the Fischl nodes. And finally, wave EI, represented by -1, governing dynamic wave propagation.
I picture this like a perfectly still ocean. That's the space, the 0. Then a drop of water hits the surface. That exact point of impact is the point T, the 1.
And the ripples spreading out are the wavy, the -1.
And according to the manifesto, the interaction of 0, 1, and -1 produces the entirety of physical mass and energy.
Yes.
And here's where it gets really eerie. He uses this identical math to derive the exact mass of an electron at 0.511 MeV, the muon at 105.7 MeV, the W boson. And it flawlessly predicts nuclear magic numbers.
Right. Magic numbers are specific numbers of protons or neutrons that result in highly stable nuclei, like helium-4 or oxygen-16.
Our current models struggle to explain cleanly why those specific numbers are magic.
What's fascinating here is that in the TDUFT framework, a nuclear shell is geometrically identical to a particle resonance node. He states the tetrahedral geometry of a helium-4 nucleus is the exact same mathematical object as the loop equation that calculates an electron's mass.
Okay, I have to push back here. Math on a chalkboard is one thing. String theory has produced beautiful math for decades. But a physical gigawatt power plant is entirely different.
Mathematical elegance does not guarantee physical reality.
Right, it's like a tuning fork. The math tells us the exact shape the steel fork needs to be to hit a perfect anode. But the math itself doesn't make a sound. You still have to forge the metal and strike it.
And that is precisely why the manifesto dedicates the vast majority of its pages to engineering blueprints. Dukas provides the industrial specifications to actually build the tuning fork.
So how is this physical tuning fork built? Let's walk into the blueprint of the 10-meter commercial 5 fusion reactor.
Let's break down the core. It centers entirely on a 3-meter diameter, 15-meter-long target made of californium-249.
And it's not just a flat piece of metal. It's machined into a phi helix with a 170 nanometer pitch, like a microscopic spiral staircase.
Yes. Into this meticulously shaped target, the reactor fires a beam of titanium-50. Specifically, 12 separate titanium injectors firing 10 to the 13th ions every second.
Spiraling in at the golden angle, 137.5 degrees. They're writing the curves of the spiral staircase.
Precisely. This is the D2 stage, the circulation of the titanium beam. But the most striking choice isn't the californium, it's the containment vessel.
Oh man, this part. Conventional fusion uses multi-billion-dollar cryogenic superconducting magnets. And what does Dukas use? A rock.
He uses a 1,200-ton solenoid made of Bar, Vermont granite.
I had to read that 3 times.
No.
Bar, Vermont granite. We are replacing the most complex magnets on Earth with a block of quarry rock you might use for a kitchen countertop.
Well, Dukas is very specific about why. It operates at room temperature. The granite acts as a D10 containment field. Because of its specific diamagnetic susceptibility and effectively zero coefficient of thermal expansion, it acts as the perfect acoustic and magnetic resonator.
So it's an active component of the physics. The document says the granite locks the phi lattice at exactly 144 Hz.
Exactly. By naturally resonating at 144 Hertz, the immense mass of the granite stabilizes the phi orbitals of the californium target. It doesn't need to fight thermal expansion because the granite harmonizes those forces.
Like a giant pipe organ inside a cathedral. The titanium beam is the breath. The californium target is the flute. And the 1,200 tons of granite is the cathedral architecture holding the acoustics perfectly steady.
And because of this stability, it doesn't suffer from intermittent pulsing. Dukas claims the reactor operates at an 87.6% capacity factor, continuous baseload power.
Not 6 minutes a day. And the cascade happens in stages. D2 is the beam, D3 is the lattice coupling, and then D4.
D4 is the barrier penetration stage. This is where the geometric boost of 2,207 times manifests physically. It compresses the Coulomb fusion barrier,
Taking that impossible 0.034 picobarns up to 70 picobarns, meaning the fusion actually happens, the zipper lock.
yes, which leads to D5, where energy is extracted. This yields 1.2 gigawatts of continuous thermal power.
Which is enough to power roughly 1 million average homes. And it does this by coupling with zero-point vacuum energy.
Right.
Okay, pause. Zero-point energy. That sounds like pure snake oil. You can't get something for nothing.
In quantum mechanics, the vacuum is not nothing. It's a seething soup of virtual particles. We know this energy exists through the Casimir effect.
Right, where two plates placed nanometers apart will actually push together.
Exactly. Dukas proposes the D5 cascade creates a macroscopic Casimir-like asymmetry, extracting thermal energy from vacuum fluctuations. It's tapping into an ambient field.
Mind-blowing. But 1.2 gigawatts is only half the story. The fusion reaction fundamentally changes the atoms. You're smashing titanium into californium. What comes out totally redefines nuclear waste.
Conventional fission produces toxic actinide waste that must be buried for tens of thousands of years.
But the Phi fusion reactor, the document says it produces a pure profit matrix.
The reaction directly targets a doubly magic nuclear shell closure at Z equals 120. Z is the atomic number.
Element 120 is way deep into the super heavy elements.
Yes. And the document claims the reactor acts like a perfectly tuned sorting mechanism. 89.6% of the fusion events become perfectly stable, element 120.
Yielding about 100 grams of pure element 120 a year.
9% decays into elements 118 and 116, and 0.5% captures extra neutrons to become element 126.
Wait, a massive logistical question here.
Yeah.
The reactor is generating 1.2 gigawatts of heat, mostly through neutron emission. Doesn't that make the 1,200 tons of granite dangerously radioactive?
This is where the material choice is brilliant. Granite is largely silicon dioxide. The neutron cross-section of silicon is exceptionally low, around 0.11 barns.
So the neutrons just pass right through the granite.
Essentially, yes. Like glass is transparent to light, the heat exchangers outside absorb them. The tiny fraction of silicon atoms that do absorb a neutron becomes silicon-30, which has a half-life of only 2.6 hours.
Oh, well.
After 2.6 hours, it decays cleanly. There is zero long-lived structural radioactive activation.
Okay, but what about the super heavy elements? You are creating element 120 inside a gigawatt core. The document says it uses magnetic separators to pull these ions out before they decay. How?
The D4 lattice field acts as an intrinsic mass spectrometer. Because element 120 has a highly specific mass and charge, the resonant frequency of the granite naturally forces the ions into a distinct exit trajectory.
Sorting them away from unreacted material.
Exactly. Every atom that exits is a sorted, high-value commercial product.
Let's consider the scale. 100 grams a year, that's about the weight of a bar of soap, maybe the size of a small coffee can. Why is a coffee can of element 120 so important?
Because until now, super heavy elements have only been synthesized a few atoms at a time, literally single atoms that exist for fractions of a second.
Right. Scientists throw a press conference when they detect one atom of oganescent for a microsecond.
So having 100 macroscopic stable grams is like transitioning from rubbing two damp sticks together to owning a fully operational oil refinery overnight.
And it's the core catalyst for entirely new industries. Let's do the economics, because they defy standard models. The capital cost to build one reactor is $2.2 billion.
Which is roughly 1/10 the cost of IPA.
Driven down because machined granite is incredibly cheap. Now, selling the 440 megawatts of net electricity brings in $1.05 billion a year. That pays for half the plant. But then the element 120.
Dukas values it at $10 million per gram.
So 100 grams is exactly $1 billion in pure revenue. Plus, the byproducts sell for hundreds of millions. Total plant revenue is projected between $2.2 billion and $2.7 billion every single year.
The payback time for the capital expenditure is less than a year, roughly 10 months.
After that, it's an infinite profit machine.
It creates a self-funding, closed-loop economy, subsidizing the cost of generating limitless, zero-carbon electricity.
And the applications for Element 120. This is where it reads like sci-fi.
First is quantum computing. Currently, quantum computers struggle with noise that causes qubits to lose their state. But the exact resonant stability of element 120 can create flawless nuclear spin qubits.
With quantum coherence times of over 1,000,000 years, current times are measured in milliseconds. 1,000,000 years means error-free quantum processing at room temperature.
Then there is data storage. By utilizing nuclear isomers of element 120, Dukas claims we could achieve data densities of 100 zettabytes per gram.
I have to stop you there. A zettabyte is 1,000,000,000,000 gigabytes. The entire sum of all digital data in the world right now fits into roughly 100 zettabytes.
Yes.
You're telling me we can take the entire digital footprint of human history and put it onto a speck of metal the size of a grain of rice?
That is the calculated density in the TDUFT framework. You are storing bits within the multidimensional resonant energy states of a super-heavy nucleus.
Can the global market even handle this kind of technological shock? If you obsolete every server farm, every battery factory, every power plant overnight, the economic whiplash would be devastating.
It is a valid concern. The introduction of such disruptive capabilities is usually accompanied by massive societal upheaval, but the document focuses on potential, like deep space propulsion.
Right. Catalyzing hydrogen-helium-3 fusion drives.
Achieving specific impulses of 1,000,000 seconds.
Cutting travel time to Mars from 9 months down to 30 days.
It removes the primary barrier to interplanetary colonization.
But the most disruptive application to everyday life is what it does to mundane objects. The batteries in your remote, the lighting in your house.
This brings us to scale and variance. Dukas emphasizes that the exact same quadratic equation and geometry apply identically whether the device is a 10-meter power plant or fits in the palm of your hand.
Which brings us to the Phi battery. The document details doping an organic molecule structure with just 4 micrograms of element 120, a fraction of a grain of salt, in a standard AA battery form factor.
It extracts zero-point energy directly from the vacuum at a vastly smaller scale.
And the metrics. That single AA battery holds 1 megawatt-hour of energy. Your house uses about 30 kilowatt-hours a day. This tiny battery could run your entire house for a full month.
It can charge in 30 seconds and last 1,000,000 cycles.
You could put a handful in a Tesla, and the frame would rust away before the battery's degraded.
It decentralizes energy storage entirely, no more lithium mines. But the ultimate unification is the Phi Fusion light bulb.
Oh man, Appendix D. A standard screw-in light bulb, mass manufacturing cost, exactly $15.
Inside is a 3-millimeter Phi crystal doped with californium-249, surrounded by a miniature granite containment ring.
Performing actual nuclear fusion on your nightstand.
But completely shielded, the granite and quartz absorb 100% of the non-visible radiation.
And it extracts 7.236 watts of zero-point energy to run itself. It uses a phosphor coating to convert the fusion energy into 1,000 lumens of light, rated for 57 years of nonstop light.
It replaces the power grid, the battery, and the LED all at once.
I gotta play devil's advocate. We are talking about putting californium into a child's bedroom. What if my kid knocks the lamp over and it shatters?
The manifesto addresses this. The fusion is 100% dependent on the precise Philatus resonance of that intact granite shell. Any physical damage that cracks the crystal causes immediate lattice decoherence.
Meaning the tuning fork breaks and the musical note stops.
Exactly. The reaction quenches, shuts down in less than a microsecond. It is fundamentally incapable of melting down.
With claims this massive, there has to be a way to prove it. We can't just take a 2026 manifesto at its word.
Dukas offers a highly specific upgrade path and killshot experimental tests for a 2027 prototype.
Phase 2 is called the double Phi helix.
Yes, Dukas proposes adding a second counter-rotating californium spiral, offset by exactly 137.5 degrees.
This sounds exactly like discovering the double helix structure of DNA, but for nuclear physics.
It is geometrically analogous. By utilizing chiral decoupling, the reactor activates the D6 electromagnetic channel.
And the resonance boost jumps from 2,207 all the way to 15,127. Element 120 production rockets to 685 grams a year.
The capital cost goes up slightly to $2.35 billion, but revenue jumps to nearly $9 billion a year. The payback period drops to just 32 days.
32 days. What happens to global economics when the ROI on a power plant is a month? But tell me about the falsifiable tests. How do I kill the theory?
He provides 4 tabletop tests. First, measuring an acoustic and electromagnetic sideband emission at exactly 8.03 Hz.
If it's not there, the math is wrong.
Test 2. Subjecting a niobium ring to the excitation frequency will exhibit a periodic weight transient of 10 to the -8 grams. Controllable anti-gravity effects.
Wow.
Test 3 involves an 808 nanometer neon Raman cavity to measure specific lattice spacing, but the ultimate test involves resonant lifetimes of atomic nuclei.
He predicts that the ratio of the resonant lifetime of oxygen-16 compared to helium-4 must be exactly 5 to the 4th power, which is 6.854.
Yes. If an independent lab measures that ratio, and it is 6.853 or 6.855, the entire theory collapses into dust. If it is exactly 6.854, the theory is fundamentally validated.
It is the ultimate line in the sand. Well, we've covered a massive amount of ground today. We started with a simple quadratic equation and followed it to the geometric alignment of subatomic particles.
Exploring how geometric resonance overcomes the picobarn barrier that has plagued fusion for 70 years.
Theorizing a reactor that acts as a perfect sorting plant, producing highly stable element 120 instead of radioactive waste.
And how that element trickles down into everyday life through scale and variance, enabling megawatt-hour AA batteries and $15 light bulbs.
It's breathtaking. This is a theoretical document, yes. But if Dukas is even half right, the physical world is about to change very quickly. Which brings me back to where we started. If a $15 light bulb can generate its own power infinitely, and an AA battery can power a car for life, it completely severs humanity's reliance on centralized power grids. Take a moment and ponder what happens to global geopolitics, to national borders, and the global economy, when no nation can ever again control or monopolize access to energy. If TDUFT is real, it doesn't just change physics, it fundamentally rewrites human civilization.